So here's a case of sample selection that we might think of as a good example. Remember, sample selection is a problem when we're estimating an equation like test score equals beta 0 plus beta 1 times class size, and we have this sample itself selected on the basis of the outcome. So the outcome is test score. So draw a little exaggerated example. Suppose we have a scatter plot of class size and test score, and we have a bunch of observations for, say, school districts or individuals, and these observations look like this. And imagine if we instead had an alternative test regime where it was voluntary for schools to test. So some schools would take the test and other schools wouldn't. And we might easily imagine that the schools that think they're going to get really low test scores, they're the ones that decide not to take the test. And so we might imagine there's some threshold here, and schools below this threshold do not take the test. They don't administer the test because they say, oh, our students are special, they need to be evaluated in other ways. And partly, of course, there's an argument for that, but we might also think they don't want the students to take the test because they don't want the voters and others to know that their school district is not delivering on performance. So what happens? Well, let's extend this line over here. So now none of these schools here are observed anymore. They're not in our database anymore of test scores and class size. Now notice our original relationship looked kind of like this. It looked, the way I draw the data, like it was probably a negative slope. But once we have that test score data, no longer have this data in the sample, our estimated slope might look like that. It might look like now class size is positively associated with test score rather than negatively. And that's because all these schools with big class sizes, all the ones with low test scores drop out, and the only ones that remain are school districts that have large class sizes that have high test scores for whatever reasons. They are happy to continue to be tested, and they get tested. So you can see how this can bias our estimate of the slope. Our interest is in the slope beta 1. How much does class size affect test score? If we didn't have sample selection, we would estimate the black line if we didn't have sample selection. But with sample selection, we instead estimate a biased coefficient. It looks like it's upward sloping. So that's a nice example of where sample selection matters. And of course, if we got the data, we started running regressions, the data aren't going to tell us that there's a sample selection problem. It's our knowledge of the context of the test regime in a particular area where the data come from. It's that contextual knowledge that tells us that there's a sample selection problem.